Welcome to this tutorial video. Today we'll be looking at the compounding interest equation, part 2. In part 1 of the compounding interest equation, we looked at how to apply this particular equation to calculate the value of some investment n years down the track, given the annual interest rate r and the number of terms n, and this is used for compounding interest. We now want to consider what happens if we're looking at compounding interest over different periods, not just a typical annual period of compounding interest. So we could be looking at a quarterly compounding interest, whereby every quarter of a year our interest is calculated and invested back in to add to the principal. We could look at the monthly, whereby at the end of every month our interest is calculated and added back to our investment. Same with fortnightly, weekly, or even daily. A lot of banks calculate interest when they're charging interest at a daily rate to maximize their return. So when we're doing this, we need to consider that quarterly occurs 4 times a year. So the number of periods will be 4 times. So if the year was 1 year, that will give us 4 periods or 4 quarters. When we're doing it monthly, the number of turns has to be multiplied by 12 because there's 12 months per year. Fortnightly 26, weekly to 52, and daily up to 365. However, whilst our periods go up, our rate has to be divided by the same factor. So if we have an interest rate, say, of 10%, its quarterly interest rate would be 10 divided by 4, the rate divided by 4. Monthly, the rate would be divided by 12. Fortnightly, the rate would be divided by 26, and so forth. We'll look at some examples now to try and explain this and clarify it as we go. So let's have a look. $1,000 is invested at 5% per annum, and this one is compounded quarterly. We want to know what its value is in 20 years. First of all, let's look at the number of turns. 20 years multiplied by 4, because it's quarterly, and there's 4 quarters per year, gives us a total of 80 quarters. So we're trying to work out what is the value at the end of 80 quarters. Our initial value or investment was $1,000. Our rate was 5% per annum, which means per year. However, because we want to calculate per quarter, it's really 5 divided by 4% per quarter. Now that our rates are in quarter and our terms are in quarters, we can intercept them, rather we can substitute them into our equation. So the initial value is $1,000. Our rate is 5 over 4% per quarter divided by 100, and our number of turns is 80 quarters. Now this 5 over 4 over 100 is easily expressed as 5 over 400. Simple mathematics, 5 divided by 4 divided by 100 is the same as 5 divided by 400. We simply take the divide by 4 and join it in with the 100 as the denominator. Now we've got our growth factor. We multiply that by the factor of 80 and we get our response that in 20 years, 5% per annum investment compounded quarterly when we started with $1,000 will be worth $2,701.48. It's paramount that we understand that our rate per quarter and our terms per quarter must be the same to make this equation work. Let's complete this, or repeat this equation rather, looking at what happens when we compound it monthly. So there's 12 months per year, so after 20 years that represents 240 months. So we want to know what is the value of our investment after 240 months. Our rate is 5%, however we want to do it per monthly, so it's 5 divided by 12 as there's 12 months in the year. We substitute this value in, initial value of 1,000, a rate of 5 over 12, and terms of 240 months. Now that 5 divided by 12 divided by 100 is easy to express as 5 over 1200. Gives us a growth rate of approximately 1.0042 raised to the power of 240 multiplied by the initial investment of 1,000, a return of $2,712.64. Let's repeat this example again. This time we're going to compound our interest fortnightly. So 20 years multiplied by the 26 fortnights per year gives us 520 fortnights. So we're trying to calculate what's the value of our investment after 520 fortnights. Our initial value is $1,000 being invested. Our rate was 5% per annum. However, it must match our terms in fortnights. So 5 divided by the 26 fortnights per year gives us a percentage rate per fortnight. We substitute that into our equation, as we've done in the last 2 or 3. So 5 divided by 26 divided by 100 is the same as 5 divided by 2600, all raised to the power of 520 fortnights and multiplied, of course, by the $1,000 initial investment. That gives us a return of $2,715.67. Repeat once again for compounding weekly. So weekly, there's 52 weeks in a year. We multiply that by 20 for the 20 years. That tells us in 20 years' time we will have had 1,040 weeks go by. So what's the value of this investment after 1,040 weeks? Initial investment of 1,000, a rate originally of 5% per annum, but when we divide it by the 52 weeks in a year, we get it back to a rate per week. Our rate and our terms are in the same units, so we can substitute those into the equation. Again, the 5 over 52 divided by 100 can be expressed as 5 over 5,200, raised to the power of 1040 for the number of weeks, and of course multiplied by the original investment of 1,000. Gives us a return of $2,716.98. Our final one is the same details, except we're going to compound our interest daily. So 20 years multiplied by 365 days is 7,300 days. 7,300, we want to work out what is the value of our investment after that many days. Our initial value was an investment of 1,000. Our rate was a 5% per annum. However, that's going to be 5 over 365% per day, so that our rate in days matches our terms in days. Substitute it into our equation. Again, the 5 on 365 divided by 100 is easier expressed as 5 over 36500. Multiply that, or rather, raise that to the power of 7,300 and multiply it then by 1,000. Gives us a return of $2,718.10, compounding daily. A quick summary. There's our equation for our compounding annually. To make it easier, compounding quarterly means we take our annual rate and divide it by 400. We take our terms and times it by 4 because of the 4 quarters in a year. Compounding monthly, instead of dividing by 100, we divide our rate by 1,200 because of the 12 months in the year, and we multiply our terms by 12 also because of the 12 months in the year. Fortnightly, instead of dividing by 100, our annual rate is divided by 2,600 because of the 26 fortnights in a year, and our terms is multiplied by 26. Just as the weekly is divided by 5,200 and multiplied by 52 terms. And finally, if we're compounding daily, our interest rate is divided by 36500 and multiplied our terms by 365 because of the 365 days in the year. Finally, let's try this example. $50,000 is invested at 7.5% per annum. What's the value after 10 years if this is compounded? A, annually, B, quarterly, C, monthly, D, fortnightly, E, weekly, and F, daily. I suggest you pause this video and make your calculations, and join me when you've done. Welcome back. Our answers for annually are as shows, for quarterly, for monthly, for fortnightly, and finally our weekly and our daily calculations. I hope this video has helped you to better understand how to use the compounding interest equations when we have different periods of compounding, such as our annually, our quarterly, monthly, fortnightly, weekly, and daily. Once again, thanks for watching.